So R5 is rational expressions. These are algebraic fractions, so all the rules of fractions we talked about will now be used for current numbers. A little harder, but it's a good fraction, and it's not a big deal. If they're fractions, then you're gonna hate it, and you better go with the fraction. Okay. Let's start off low.
Like that. Like that.
Oh, by the way, I graded everything and there was grade. If you haven't done your corrections, I'll grade those. after you do.
I was trying to submit the corrections, but it's closed.
Close? Yeah, me too. Okay,
And I had text you on mine, but you didn't answer.
oh, I haven't checked today. I'll open it. It's supposed to already be open, but I will fix that. That'll close at the end of spring break. Upload your corrections by then and I'll give you your credit back. If you haven't already done so, if you already did it, then you're good. You already know your grade. Submitted midterms, so whatever your grade is now, you should reflect that. So if you haven't done the test corrections, then that means your midterm is not going to reflect your updated grade. That makes sense? Midterms don't matter, it's just a progress report. How you are so far, but since you haven't done the exam yet, or some of you haven't done it yet, then one needs to be corrected. Then there's a lot of stuff that hasn't been factored into your grade. Okay, keep that in mind. Anyway, if you get a email saying that you're failing or you're behind or you should talk to me, that means do your test corrections, catch up on your homework. Okay? That means, okay.
For me, because I did send the test corrections from the first test into the practice test one. And you said that that one was.
Yeah, yours, I did grade yours properly. Yours was like correct, right?
When did you send those emails?
I don't know when you'll receive them, but I submitted them today. I don't know when you'll get them. Assuming you're failing. If you're not failing, then you won't get one. Okay. You are behind and you won't get one.
I mean, too, I go, what? Wait. I go, me, I'm back. No, I ain't, bro.
You get nothing when you're talking. Just keep up on.
I tried one day to. One over here. Wait, let me see, where's yours? Okay, yeah. Yeah, no, I tried to use the charge my iPad. Okay.
Okay, to find domain or rational expression. You can just look at the denominator and then plan around. it. We all know that you cannot have 0 in the denominator. Basically, though, what you do, step 1. Set denominator. 0. So denominator is 0 when not have 2 in there, but everything else is fine. Create a number line. And find out. Okay. With the fact. X cannot be 2. Because it makes it 0. This little number line right there. There's a hole in it. Everything after 2 is fine. Everything before 2 is fine. That makes sense? So. You take into account section after Q, how would you write it? I'll slow down. So look at the before and after part. So, okay, what are the x's allowed? Above 2 and below 2, how do you write that?
What are the X and allowed above?
The X would be greater than 2, right?
I can't even think right now. I don't even. I'm so
So, yeah, how much-
tired. I'll probably just quiet.
Hold on, yeah.
Thank you. Okay, so what is?
Yeah, again.
Yeah, so look at the number line.
Okay.
There's a hole at 2.
Yes.
What do you represent? Everything after.
Wait a minute.
It's parentheses, right, unless it's included.
Yeah, the view parentheses on 2.
Okay.
How do you write it?
So would it be parentheses? Button two. I want to do one like infinity again, because it goes on forever.
For sure, it has a 2 till infinity, right? You all agree with this?
Oh, yeah.
And how do you write the before part?
What?
Before 2. Everything before 2, below 2.
Negative infinity, yeah, negative infinity. Yeah,
And so this part right here. Visualizing this part for you. This part over here. Is this part, this,
what do you say the little slope thingy?
union.
What does
Yeah,
it mean?
You write that prettier.
A union. What is it slope there?
What does it mean?
It's basically like saying that this in this for the going, but not anything.
Union of 2 pieces. Okay, so anytime you have a rational expression, as per domain. At the bottom of 0. And figure out where the problem is. Step 1, right? We solve for x, we get 2, so now. You plug in 2 into this function, you'll have 2 minus 2 on the bottom, right? No problem. So the domain means all the inputs that are allowed, all the x values of the expression. Do a visual. Graph for x plus 7 over x minus 2. And then x equal to 2 is a vertical line at 2. You see how skips that point, right? It just jumps over here. So the domain is everything except this value, because the function can never go there. It's infinitely close, but never goes. Then it jumps right after. So it hits every single x value. Except this. That's what domain means, right? All the x values that your graph covers. Everything that it covers. It's everything except this. Okay.
Everything we brought covered, but what? The
Domain
domain means
means
everything we brought covered, but what?
but two. In this case, two is not included.
So was this a formula, right? Just that one? Or that's just.
Trying to give you some steps on how to do this. The only formula or rule, I guess I would say, is whenever you do spatial expressions, or find the domain of it, at the bottom is zero. It's the part that will always be the same. This will lead you to a number line. Number line will help you visualize what it's supposed to. Okay. Also graph it and look at it. Help to verify. Domain means a set of all inputs of any function. Inputs of all x values that are allowed. We're allowed to use any value except two. That's why we wrote it this way. Okay. Range would be all the y values it touches. Any questions on how to find the domain and what is a domain?
Please. Be your guest.
Oh, yeah.
Okay.
So let's go over what is a domain, what is this case. You guys cool on this page?
Yeah, look for it.
Who's not called yours?
What is that?
Right in the bottom.
That we should not think of.
So, yeah, it's a. Right now, I can't even think of that.
It's cool on this page. Let's talk about what is domain and what is range. For those under the assumption that you knew what it was, and I don't think that's a fair assumption. Okay. So picture the domain. It's just a big set. Value, doesn't matter what it is, a function can be almost anything. Oh, blurry here.
Simple.
So in here, let's just put. Let's create a
Chart.
bunch of names.
Yeah.
In range, the range is the output where each of these things are. And they can. The phone number. This will have phone number with the outside. So, pick up the numbers. I get the number back.
Why?
I think it was, no?
Yeah. That's crazy.
The numbers don't matter, you can put whatever you want. Maybe we got 6. Let's say there's a function in the middle. Call it. F. The function sends every input and assigns it to a value. That's what a function does. That's what it is. The definition of a function is that every input can have only one output. Right? Meaning one input cannot go to 2 places. So you can all go to the same place, but one thing cannot go to 2 different places. So let's say John has this number. James has that guy. Mike has this number. That man has that number. Mario has this guy. Apparently, all the inputs have one output. They're all being assigned a phone number. Only one phone number. Okay. So if that's the case, then it fits the definition of a function. If all of a sudden we have, let's say, I don't know, Larry has 2 phone, or he has like 2 girlfriends or something. Then that guy is, this is no longer a function. Right? It violates a definition. But if they asked you what is the domain, you would say everything that is input. Range is everything that's over. Okay, if we use an actual mathematical function. Say I had the numbers 1, 2, 3, 4. And the range was double. That leaves some space. The function here would be 2 times x. Put the function on the bottom. F of x will equal to 2x. So this is going to be assigned to 2, assigned to 4, assigned to 6, assigned to 8. So the after domain, you would say, instead of all x values in here, 1, 2, 3, 4. They ask for the range, you would say, well, all the outputs 2, 4, 6, 8. So this is a function. This one is not because Larry effed it up. Right? That makes sense. In a nutshell, that's the definition of a function without giving you the fancy math definition.
I like these things.
Okay.
You should be just.
So now let's look at the mathematical equations and see what is the domain, what are the functions, like you random graphs can you tell? Okay, let's look at some graphs. Think about it.
Could you
So,
go over this page again?
yeah, so this is a function, let's say. File number 2. Not a function. Because Larry has 2 outputs. But he violates the definition. This one is a function. The definition of the book is a little more complicated, but essentially it boils down to this one idea. Every input must have only one output. Okay, that is a function. Function can be many different things.
Every function that only have one output. How would you?
Yeah, every function can have exactly one output. For every input. Like we just talked about something. Since they're talking about domain in the home one, you should at least know what something is. The domain was written. Okay. You use some graphs. You cool with this part? More about function after. But we just mentioned it a little bit right now. Okay.
It will.
If we pick some random functions, The parabolas, we talked about that last time. Think of visual help. Look at this problem. At the equation, is there anything you can't plug in? Do you see any like weird issues? Is there a number that wouldn't be allowed? For X?
Squares,
Why?
Like any number that you choose for X.
zero,
Plug in 0, what happens? Good.
1.
1 squared. 0 plus 2 squared. Look at the graph. You're going in both directions, right? All the way to positive infinity and negative infinity. Keep going. Right. Eventually it hits everything. So the domain is all real numbers. That's what we told you in last class. This is properties for quadratics. We said the domain will always be all real numbers. You can see it because it keeps going. What is but range though? What is the lowest value? Yeah. 0 is right here. The lowest y value is 0.
Okay.
And then it keeps shooting up to the top forever, so the highest would be infinity. 0 to infinity would be the range. And it would be everything on the x. Okay. You're going left and right, so with negative infinity to infinity. Based on the graph, you can see now. If I shift this graph a little bit. Now what is the range? That's the lowest y value. Then you keep going upwards, so you would say 4 to infinity. That's what visually what range means, any kind of picture, any kind of graph. You see, okay, what is all the y that's touching? What is all the x's? X's are all the inputs for a circle. Outputs is all the range values. Anyway, we'll talk more about this in chapter 2, but here's a brief introduction to it. Do another one. Okay, so what do we do first?
the parentheses,
About the parentheses? You could multiply them out, but what was the first step on the last example? Yeah, set them to 0.
X is 0.
Once we set them to 0, we will solve first. When you have 2 products equal to 0. You're allowed to set each one individually. Correct. Looking at the bottom. The question is, in order to find a domain for this. Whenever you have this type of question, you set the denominator equal to 0. That's all you do. That's it. Solve for X. We have two problem areas. What's the two? Don Numberline? Okay. So you see how there's two problem areas, two holes. Cannot use them, but everything in between, everything after is cool. So how do I write this as an interval in between? Right, here to here, how would you write it?
From where to where?
The center part. -1/4 to 3,
Negative. Or negative.
or just in the middle?
1/4, negative.
But this means from here to here, include parentheses, you don't want to include the endpoints. If you did, they were filled, you put a bracket. So if they're not, okay, so we do this. So now how do you write everything after 3? Three, so keep going to the right. That's this piece. Now the piece before. -1/4. I'm gonna union with everything else. And then, yeah, biggest most negative goes first. Draw your number line and create sections for each entry. That makes sense?
Yes.
Before, everything in the middle, everything after. In order to find the number line, you have to solve for x on the denominator. That's all we're doing. Look at the bottom, solve for x, put on the line, find out what's in the middle, after, before, etc.
That's it.
All that's what we're trying to make. So there's the main, it's this.
Everybody.
Any question number 2?
It's on the homework, would I still write the domain, the responses, all three of those?
If they ask for interval notation, yes.
Okay.
The use set builder. It'd be written like this. X, instead x. Now it'd be equal to. This one, it was -1/4, right?
What is this called?
It's interval notation.
What is this called? Yeah, R5. No, that subbuilder thingy.
They might have you do like this at first. You just plug in the numbers. Okay. But
What is
Thanks.
that?
I expect you to do this.
Oh, I see.
X cannot be 3, x cannot be -1/4.
It might ask us to write it like that.
They'll probably write it for you, and fill in the blanks.
Did I write that down?
The owner is gonna walk you through it. But I want you to know what it means and how to write interval. You need to be able to do it. Later, it's gonna be like this, and the examiner will probably be like that too. Okay,
In interval notation,
yeah, I expect you to be able to do interval. Well, they write this part for you. You just put in the.
Oh, the numbers. Okay. Oh, don't even know that. Never mind.
The question get harder and harder. So then, you can tell it's already factored here. Eventually, you have to factor yourself.
Oh, we're still not done.
Oh, it's tough.
So that.
So I just want to point out that the level of difficulty. First, it is a simple term, you set to yourself, right? Here you get two of them, self right. Next one, you have to factor it yourself.
I don't get it. Wow. I'm joking. Right.
Okay. So write down the denominator, so it's zero, first part. Denominator, said it's zero. How do we solve this? Go back to the quadratic equation section. You could, yeah, very similar.
You would factor out the X from X and
Yeah, factor the trinomial, do the trial area or AC either way. You remember you look at the factors of 63 and add up to 16. Times what is 63? And 7. All right.
Oh, yeah, 63.
What is 9 plus 9? Whenever you get to that part, you got to factor using whatever technique and what's required basically. Set each part to 0. Correct. Line on the line around those 2 points. But we write that everything below -9.
interval notation or
Yeah, let's do interval because we're gonna get used to it anyway.
the parentheses, a negative infinity, with 9. It's parentheses union.
After. It's always gonna be easier because someone knows these values. We're doing it an extra step because you're gonna have to do that anyway. So. Let's move on to, reducing.
Using domain.
Just reducing the fraction of the rational expression. Another example. Questions on three? Move on to something else.
So then for step one, 9 and 7 were just the factors of 63
For which one?
for step one.
Yeah, it's similar to the AC method. Except, you don't have to do the grouping part because there's the one on the export. It just finds the factor 63, factors of C, that add up to B. So 9 times 7 is 63, 9 plus 7 is 16.
Oh, okay, I was just wondering what happened to the x squared in 16, but
Yeah, if you FOIL all this out, multiply to get these three terms. What would you do here?
This is.
Another question. Simplify the rational expression.
Like it. Something pretty.
To remind you. When you reduce fractions, we factor, I told you to factor them first. First week of class, I said the reason things cancel. So they contain a common factor. 4 is 2 times 2 and 6 is 2 times 3. These twos cancel. It is 2. Right. Think of it this way, because that's what we're gonna be doing. With the algebraic terms, you have to factor first. Because before you do it in your head, yeah, the 2 goes into both, but when these get super complicated, can you do this in your head? No. So factor first. These are already factored. So what would you do?
Solve it. Couldn't just.
Yeah. What is this common term? Well, like over here, we had a common factor that's canceled, right? What's the common factor here?
1 minus 3.
1 minus 3 is the actual term. This is separated by multiplication. Where I told you can only cancel if it's separated by products. canceling these two because they are the same factor with these two. Right? That makes sense?
Yes. Why is your answer?
Answer. Reduce the fraction.
It says that that's in that example. Where it says simplify the rational expression is the four, meaning like example 4 is step 4.
It's a new example,
Oh, okay, I was. No,
completely unrelated to the last one. Moving on to something different.
What are we doing?
We're simplifying the irrational expression. Basically. A fraction. Same thing on part B. Reduce the fraction. But can you cancel, or how do you cancel? When do you cancel?
can't you just take out 1x from the 7x and then cancel out the 2 6x's
What from the top?
from the bottom? 7x subtract. X. You get a 6x and then subtract the 2 6x's. Or they would have to be across.
Yeah, these don't combine. That pertain 6 and 7?
No, from the bottom one, like if you were to subtract 1x from the 7 to make it a 6x.
You could, but it won't help you. Things only cancel when they're products, right? So we need to create products. The only way to do so is a factor. What can you factor from the top? 6. 6. Factor 6. What do we have left over?
1 3.
X and what? X minus 4. All right, what about the bottom? What do they have in common?
It would be 7 and then parentheses X. A minus 4.
Now what can you cancel?
The X and 4.
You see why?
So that's.
It's the same as the products. So yeah, 6 times this, 7 times that. Only then can you cancel. When you have the bottom. Cancel any other time. Don't want to see this type of nonsense on your exams. Cancel.
Why? Because it doesn't have nothing else at the bottom. It's not timesing in.
Isn't considered not a product.
You don't cancel. Not a thing. I know it's tempting, but it's not a thing. If you had. Then you can cancel.
Yeah.
The difference. Okay. I know someone's gonna do it. Somebody always does it. Remind you if you do it.
You bring it down with open.
Yeah.
Yeah, as long as they're times, as long as it's times in between each little number. Or whatever. you can cancel. Technically, you could write it without. Parentheses. We don't have parentheses, right? Cancel could be. But parentheses, I guess, everywhere and. You guys pull on this page. Okay.
So is that not right? Oh.
That colors every. Simplify this guy here. Can't cancel anything until we factor. What can you factor on the top?
10 and 40.
Yeah, GCF at the top is 10x. When I factor 10x, what happens inside?
X. And 1.
Now, you can start canceling if you want to. You see that one of these x's will cancel one of them. Is that clear? One more step. Then is 2 times 5 times x. 5x squared is 5x times x. One of these 5s will be gone. One of these x's will be gone. Okay, because they're all multiplied. Up with 2 times x plus 4 over x. We're done. There's nothing else to do. Fly back out, I guess. Anyway. You don't have to do this step here. This one. And so you know what? 10 divided by 5 is. One of these counts as one of those. So this one's gone and I lose one of these, 1x left. However you want to think about it. Just show your work and get here. Any questions on number 5? I'll multiply the 2 back in.
Which one would you want as the answer? The
I
2
like this.
in or the 2 out?
I don't know what the homework wants.
That's the next reading.
I'll take this.
These are the 2 out. Oh, that was like.
Either one is fine. Okay.
Oh, when are you gonna upload this, this video to the online?
For today's, maybe it's last time.
This video for us.
Like tonight. I'll put Tuesdays and Thursdays. Today's and last time.
Okay. Just like, try to rewatch it over for spring break.
All this depends on factors, right? Factor can't get you to the translation step. This one. You have to do trial and error on the top and bottom. What was the top factor? Bottom factor.
Excellent.
Factors of 32. What are factors of 32?
I know the second one is, the bottom was 6 and 4.
6 and 4, which one's negative though? So when you add them up, it's gonna be positive. So the bigger one has to be positive.
Oh, I wrote the bottom is.
Oh. You would have been right. Back to 32 and 2 and 16.
Yeah, and 8 and
4 and 8. So it's gonna be a 4 and 8. If this is positive, then that means they both have to be negative. Negative times negative is positive 32. You add them together, they become negative. Right? So once they're factored, cancel the common terms and you're done.
And then for finding these terms, still doing the AC method as well, right?
Yeah, do AC, do whatever technique you want, just make sure it's factored. Simplified. So on these, I don't think they're gonna specify any specific way. Factor it any way you want. Okay. The difficulty of these problems will depend on how hard it is to factor. It's easy factorization, then it's quick, right? Just cancel whatever. GCF or AC. It's gonna be a little harder or a little easier. Make sure you have all your factoring techniques or your formulas with you. That's pretty much it for R5. Take a small break. Don't forget, and the spring break is when test 2 closes. So it's your responsibility to get it done. Also submit test corrections by that date. Now or tomorrow, Saturday, and then do corrections later.
I noticed for some of the work that's like past due for, or not past due, but going on like due for after spring break, it says that some of them are test corrections that are due first and then test 3, so. It's due.
They should all be due Sunday. If it's slightly off, I'll check, double check.
That would
We
be,
have it Sunday before we come back.
yes, because it says that the corrections are due that Sunday, but Monday the test is due.
I think one of them. I'll make sure both are due Monday or Sunday.
I think those were test 3.
Test 3, I wouldn't worry about it yet. I don't think they do the following. Sorry. Getting your homework done and getting food done is your goal. Before you get back. Your chance to catch it. When you get, we hit the ground running, when we get back, we'll have another. Two exams. Okay. National excellence is basically, no excellence. I think I gave you some documents about this, but I'm gonna write them again. It said. Said n root s equal to x to the 1 over n. We also said that if you have this raised to another power. Then that would be the same as saying x to the m over n. You also have that power inside. So if you have either of these, you can change to the middle. Okay. Start with some simple numbers. Simplify the square root. 5 to the 8. Where, I mean,
You're already on.
we said that root can be written as a power, fractional power. So this is a square root. For there. So it's assumed to be 2. Root 2. So the thing.
There's no number there.
Index in front of the root. Assumed to be square root. If you have a number, well, obviously that's the root. So that's technically
5 and.
yeah, basically, skip a step. It'll be 8 over 2. This is basically a power on the entire thing. You give a power to another power, we said you multiply it. Or you can go straight to the middle, saying, well, the root goes on the bottom, the power goes on the top.
Do I have to do the middle part?
No.
Okay.
This part here too.
Straight to which part?
It's the formula says, right? Root goes on the bottom, this power goes on the top. That's actually this part here. So reduce it. What is 8 over 2? What does power become? Yeah, right. 4. What is 5 to the 4th? Times. you're right.
Yeah, you're right. Right, girl, you're right, girl.
That's it.
These are my head.
Legal for powers.
No.
Using your rules of excellence. That makes sense?
Wait, could you go over the halfway point and then sample one? 5/8/2.
Yeah, so just reduce this as a fraction. 8 divided by 2 is 4.
And we're going from the,
Here, here.
yes,
Oh, so 8 times a half is 8/2. Or look at this example, or this formula, right? The root is 2 in this case. So there's a 2. The power was 8. You look at it. So you just think of it that way. Or think of it as the root as a power. And then the rules of exponents tell you to multiply powers raised to another power. So 8 times a half is 8/2. 8 times a half is also 4.
okay, I just thought there was like an in-between step for between those two.
Now it just reduces,
Because I can see how you got like the rest of it, it's just. I thought because it was like new exponent.
but you don't have to do the middle step. So here we can go straight there, in the formula number 2. It says. The root is 2, therefore it's the bottom part. And the power is 16. Looks weird. It's 16 divided by 2. Okay, that's it, that's all you do. I'm gonna give you a bunch of exponent properties, month ago. Make sure, I think it's also on that sheet I sent you. Okay.
That's two.
See that blue sheet, do you have it on here still?
I didn't get it. Oh, the blue sheet?
Yeah, one second. I think it's on there.
Oh, yeah.
Exponent properties, they're all right there. I believe I sent this to remind if you want to download it with your laptop. Multiplication rule, power to a power. Doesn't have this. You got somewhere else.
Oh, it's right there.
Give all the square root problems. Okay. I wrote all of them on some notes a while back. They're here. The root. You have double root, and then you can just do that. There you go. Any formula sheet I send you, you can use it. When you do R7, R6, pull up the square root properties or radical properties. Don't have them, and just Google radical properties. And if you can't find it, I'll send them to you, just send me a message.
And BG, she said that. You really didn't get it.
Okay. Here.
Oh,
What is there, 7?
you're right, you simplify, so. X
Seventh root.
to the
5/7. And then you go. No.
So if this is smaller than the other one, then it's not gonna reduce. Unless there's a common factor. Yeah, this, we'll need those numbers that you sent for me, hours of 3.
Oh, yeah, for what?
We need it.
You will let me get my little handy dandy notes out. First, I gotta find it. Oh, yeah. What do you want?
Hours of 3.
It is an hour.
Is it?
Yeah.
Good one.
Oh. Yeah, right now. The powers of 3 are, listen, you didn't put it in any power, okay? Yeah, it doesn't even go down.
Well, I guess it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, be 9 times 9.
Oh, yeah, it is. 9.
So you don't, say 9.
I got it.
So
How do
it
you
just be 9?
It will be. For the reason that
Not if we got this handy dandy paper.
you can't.
Oh, I.
Anyway,
Don't go over.
any questions on that?
Is on the middle part between the last thing, you just be 3/3, which would just be 1, so it just leaves it at the 9, right? Okay.
Yeah, exactly. That's exactly why.
Why?
Because of this. The property says it's 3/3, right?
Okay.
Then the first, which is 9. That's why they count. Because of this. To the nth root of -1, where n is even, will always be equal to I.
Weird.
Get rid of -1. What's that gonna be?
8I.
Square root.
Just.
Sorry. I lost the thought there. So. If they tell to write this as an exponent form. That would simply be what? If this is an exponent, get up here. So what, this is what that was.
I,
We root to
I ate. I like it, I.
when the inside goes right there. This is a power, correct? That's all they want. So they say exponent form, just use your formula. They didn't actually ask you to solve it, then do this. Yeah, what the. This means remove. Yeah, cool on the page. What'd you do with this?
We could, oh, you would put it, this is, oh, what are we doing?
Simplify the problem here. Write the instructions.
Aw.
Instructions.
I was just making sure if I didn't remember that, I need to.
How do we simplify?
The half goes to the top and to.
That's true. What does the half mean?
The top.
Are these fractional powers? Yeah, that's the answer, but what is that's not what I asked.
What did I say?
What is a hat paint?
I don't remember. The exponent.
It is an exponent, but
It'll be 0.5.
You're trying to get.
So words are confusing.
Times three.
the fraction powers are true. That's why it's real.
Five. Oh, okay.
Want to make sure you know what the powers mean. Report. To, what did it say this time, radical. Just changes to radical form. That's all. Change. Change m to the 3/4 into radical form. And this is right here. This is exponent form. This is radicals.
Oh, okay.
Fourth root of m cubed. Fourth of m, everything cubed, both are equal. Okay. Look at me when they say radical form.
Feedback.
At the bottom is over. Index of the root, so there's a 4 on the bottom. There's a 4. Seven or 6. They'll mainly ask you, use or simplify. Change from exponent to radical or radical to exponent. Not much else to say. Do you have any questions on those topics?
So would 1/2 always just be a square root? Or a root power? Or like the number, example 6, when it's 1/2. As an exponent, that would always just mean it would go into that form, right?
What happened will always be
Oh,
square root.
Be chillin'.
Oh, okay.
I drive home.
Will always be.
Or like stay or whatever.
Okay, the 1/2 is always gonna be regular root, and then you said 1/3 is gonna be cubed root. Okay.
Yeah, if they don't write the number in front, it's assumed.
Oh, okay.
They just don't write, it's like on your calculator, they don't have the 2, just everyone assumes.
And like when you're adding like certain exponents, you add it, even with exponent by itself, it's the 1 technically.
Yeah, we never write the 1. Another section. No equation. You're actually solving. Right, but notice we have a rational expression. How do you cancel? How do you cancel fractions? Remember? Yeah. Look at the month ago. You had a bunch of equations on your, bunch of fractions in your equation. Remember how we cancel them?
To cancel fraction.
Yeah, how do we cancel fractions?
Divide them, then multiply them.
They multiply everything by something, you remember? Provided. Cancel these fractions. Yeah, everything by LCD. LCD here is 21. Everything has 21. Three divided by 3 would be a 7. 7 divided by 21 divided by 7. 21 times 3. So you would cancel all your fractions. 21 times everything put into your LCD. So here's gonna be the same thing we did before. Did this about a month ago, I think. When we first started solving equations. A while ago. So same thing. What's the LCD here?
It's 21. You have to get for the 3, 2, and 7, right?
Yeah, remember I showed you.
25.
Let's go back to basic really quick. Remember I told you right at the beginning, the first day of class, they said. Remember how to find the LCD, you have to break it into prime numbers. I said, remember this because it'll be important. Now it's important.
So how do you do it with the variables?
Like, factor the 12.
3 and 4.
Yeah, it's 4 and 3, right? 2 and 2.
Oh,
8 is a bunch of twos.
what if it was?
So 8 is 2 times 2 times 2. So how many twos appear here?
2,
And here,
3,
the most number you saw was
3.
3 of them. Here we have 1, 3, none, the most number you saw was. Now, if we had an X. And an X squared. What's the LCD? You would say, okay. It's the same thing. Break the X into 2 pieces. The D would be the one that has the most number of X's. This has 2, this has 1, so it'll be 1. The LCD would be. In 8 times 3. This would be your LCD. So what you're gonna do, check and see if it can be factored. If it can, then you're good. It'll be like a 21 problem, you just. Can't find. If we can factor, then it becomes. Can we factor this?
We can do the 3 and the 2 separate.
No, because they're all prime numbers.
We need factor?
Yeah.
Then anything you can do to factor this first term. 3 equals 2, but for the denominator.
Is the X by itself?
They're all fine.
Both prime, right? There's nothing we can pull out of these two.
Right.
Then the LCD would be. The fact that this came out one time. And this came out one time. So when they're prime, it's easy, but when it's not prime, you're gonna have to do this. Okay. Do it every time. So what you're gonna do is multiply every single term times the LCD like we did that other example. So. Step 1. Find the LCD. Wait up. There's no rush here.
Sure.
Everyone see why and how we got the LCD for this example. We did the 21. You know, you can't factor it, right, Ashton?
I get how to do it with the numbers is that I don't get it, but I'll figure it out as you go. Yeah, I'll figure this. If not, I'll let you know.
All right, so we find it here. The next step. Multiply. Multiply every term. By the LCD. Get 3x plus 2 times x minus 7 times the first one. Minus 3x plus 2. X minus 7 times this second one. Then again, 3x plus 2 times x minus 7 times that 0.
Right. Let me a minute to write on that. So since I understand the equal sign times a 0, can you just not do that? Whether equals 0 no matter what?
It doesn't matter for this case. You don't have to write that. You see that it's 0. 0. And now I'm going to skip steps.
Wait, that is times 0 or is it equals 0?
Times 0.
Okay, now at this point, do you see what cancels? Not an extra step in case you don't.
You just cancel what we wrote. You're about to say. Which is about to find your just with.
What cancels? These two, right? Or these two. We're left with x minus fractions. That was the goal. That's how you do it. Multiply by LCD. Now we're just doing PEMDAS stuff. Solid fractions. Multiply by 5, you'll get this. If you're negative, you'll get this. It's all correct. Yeah, just solve for x and you're done. What's x?
But yeah, yeah.
37, yeah.
I can't do simple math now. I couldn't.
There you go.
This one.
The first question is in this homework. But we'll get harder from here. Yes. Because it was crime, right? Here, they're not finding it, it's nonsense. Work would be similar. This part will be different. So some of them you may have to factor. And then figure out what the LCD is. Some might just be a basic GCF or complicated factoring. So it all comes back to factoring again. There's been like 4 sections that require you to be good at factoring.
It wouldn't be a negative 30.
You have $35.
Yeah.
$2.
Oh, you're adding it,
The
okay.
Negative is a positive.
You're adding it to.
You're gonna move to the other side. See, I told you, that's why I don't do it. Ask if steps.
Well, this probably took a whole page and the next one's gonna be harder.
Yeah, it's so hard. Do you have any questions on number 1?
Yeah, the whole thing.
Can we do it again?
Can you just verbally walk through this one? See if it makes more sense this time.
Sure, yeah, let's go with this.
Okay.
From the top.
Thank you.
Okay, so. We want to cancel fractions because solving this is annoying. Doing it any other way is harder. So in order to cancel. Find the LCD. And multiply everything by that LCD. How do you find LCD? Well, you factor each denominator. And factor because they're prime, which means. We look at how many times each of these appeared. Each factor appeared once and once, so these will both have 1 power on them. So this is my LCD. Here I'm multiplying every term by LCD. Here we have cancellations happening, which is the whole goal. Get rid of fractions. No more fractions. Now we have a basic problem from the beginning of the semester. Solve for X. Oh, makes sense.
Yeah, I still think we'll probably find a factor, but I'll figure that out later.
That'll make more sense when it's harder, I think. You have some.
Okay.
You know what I mean?
Since,
Because here there was nothing to do. But everything else will be the same. It'll be the same thing over and over again. Anything that
Oh, I don't
changes
even know why I
is this piece.
Oh, will you go, will you?
So-
Gonna-
We got 2x because 5 minus 3, right? Yes.
Oh, yeah. I don't know, what is it? That's this one. This one.
Example. The solve was only happening when you have an equation. No, we don't need to things. Terms are very specific. I think it's the only time that it pays to be math. Any other time.
It just makes everything more stressful. It really does. I'm.
Yeah.
Yeah.
The way I take notes, the way I take notes.
Just have the word on it.
I still back again, you take notes.
Are you very organized at home too?
Yeah. It's a nightmare for work, but I'm with you. It's a nightmare for work because I work with others.
Yeah.
It doesn't work.
It's a double edge, right? It's helpful and sometimes.
Yeah, there's nothing about that.
That place is just chaos. That's
That is okay. Yeah.
Never would
No,
have
I
thought
like
it.
it. It's a better.
Hear other people's tweets, exactly why it gives you every reason to not have to know.
Yeah, I have one. I can't.
My favorite part of the day was when everybody got picked up.
Yes.
Go home, get
Drop
out
off.
of here.
Drop off is my favorite part because they're in a good mood and they're all sweet because they just woke up. After that.
back to it. There's that in all the denominators, factor. How do you factor the top part? The first one I wrote. I did not write them in order. Because I'm not OCD.
I'm writing. See?
I don't wanna feel like what's it do.
I know. It didn't make it all confusing. didn't it? On purpose.
So the middle one is prime, third one is prime, the top one is. So that one factors, right? So. CD.
So how did?
Right. You want this bottle or trash?
She was using it to throw at people.
So look at the factors. X, how many times does the factor of X appear on the first term?
2 times.
Well,
I'll factor it out once.
only one time, because X minus 2 is a different factor. X appears once there, X does not appear here. X minus 2 appears. Right? So. It only appears once here and here, so the LP will contain only one of these. Now, X minus 2 appeared once there. And once here, so at most. And one of these. Okay.
That would be weird or no? I know, because it's only one.
But it's the most number of times it appears in any given spot. If I only have one there and one there, then. But this is the LCD. This is what you're gonna multiply every single term by. Step 1,
And you can just refactor them from multiplying, or you have to multiply it that way.
say it again.
Like you, when you go to write it out, you have to write it that way, or can you just factor it back in? And write it the other
I multiply it in while you multiply.
way? Could you just write it as the top one? When you go to write it out? Yeah. Is that?
First piece here. The X squared minus 2X. Well, if you did, it'd be hard to see which ones cancel. So, yes and no, I recommend you don't. I recommend you factor everything before you multiply. So let's go ahead and do that as step 2. Factor all denominators. Prime, so you don't have to worry about it. factored in it. So 3. Multiply by. By a little smaller. X times X minus 2 times this first one. Cool, if I just put it on top.
Sure.
Skip the minor step here. So. Next one times the 4. Over that same denominator. Then there's -8. Times X minus 2. These cancel. These cancel. This whole thing. One more back. Now back to just solving for it. Yeah, to here. Plus 4. Okay. Stop for a bit. Last question, we're out of time here. Use the right LCD. You know, let's cancel all your fractions. The wrong one, then you end up with something weird. Once you get here, just do your PEMDAS, solve for X, and that's it. This one. Oh, yeah. Fun, there's an X here.
That's what I was wondering.
Forgot it. At this point, multiply it all out. See what happens. Give us a quadratic sadly. You solve quadratics. Every single time. Same thing. Any quadratics.
Oh. I mean, set it to 0, right? So you solve. Plus 8 plus 8. Okay. All of this was solving for X this whole time. Solve quadratics, you always set it to 0. Now that we get here, what factoring technique would we use? I'm not gonna tell you on test 2 or test 3 what. You cancel out one of it. You cancel out one of these. 1 6.
Yes.
Yeah. Gotta factor. The first thing you do, remember on the flow chart, right, very top, that list said GCF. So check.
Oh, 5x. And that's the most time it appears inside.
No, you're right, you're right. It's back to the end. And that's the GCF of these two. Two terms. So. X is 0. 6x plus 5 is equal to 0. 6x is -5, x is -5, 6. So we're trying to solve for x. When you have a quadratic, you just have a 0 and factor every time. That's how you solve. I think it's that second. What's wrong with it? Look at your original question. Can't be 0.
You can divide by 0.
Not divided by 0. So using 0. Right here is not a solution.
So it's so solved, but it's not a solution, because it's way back.
Yeah, only this one you're following. And test them out. That's it.
No, no, homework. You only put one of them?
You only put the ones that are truly.
Oh,
Could be both, could be one, it could be. Fantastic. We'll do more of these, that spring break. What I want you to do is catch up. Set your list of where you should be. I recommend you do that practice. Practice that over exam 2, do like 3 or 4 times. Confident. Realize that the possibility is at a point that's very similar. You can really see, okay, I can do this. So, gonna be this type of problem. Then take care of that. Okay. Need to do the test corrections before you get back. Get back, that's 3.
I wanted to see if that is being fixed before the break, so.
I think so. I've already started talking to the rep.
I'll message you.
Keep putting them in your phone.
And then that also, it won't let me go to other homeworks until I finish that one.
Oh, right.
Like, even if I want to go to the questions and write them on paper, I can't.
Okay, I'll remove that requirement. It'll be fixed.
Is this one of the homework to do before we understand it? If not, if
Yeah.
so, can you move it? This doesn't make sense, though.
None of them are going to close.
Okay.
Just because they have a due date, means you can slow it.
Because it doesn't seem. I
No,
don't know.
we're gonna talk more about it.
As long as it's not, but it is